Earth, a 4.5 billion year old planet, still evolving. As continents shift and clash, volcanoes erupt, glaciers grow and recede. The Earth's crust is carved in countless fascinating ways, leaving a trail of geological mysteries behind. This is the story of Hawaii, a mountain chain over 80 million years old and home to the most active volcano in the world. In this exquisite volatile landscape, scientists hunt for clues to the island's origins. Clues that may shed new light on the formation of the Earth itself. Hawaii, the most isolated group of islands on Earth, stretching 1,500 miles across the middle of the Pacific Ocean. These 8 tropical islands are one of the youngest geological formations on the planet. With stunning beaches, huge canyons, and the biggest volcanoes on Earth. This is where paradise meets hell. The investigation into how Hawaii was formed began in 1934. Dutch geophysicist Felix Menes invented the gravimeter, an incredible machine which enabled scientists to accurately measure gravity for the first time. With his cutting-edge technology, Menes was able to calculate the gravitational forces at work on the Big Island, and using this data, determine its size. His results revealed that the Big Island was like a gigantic iceberg, only its tip was visible above the ocean. But drain away the water and its true size is remarkable. The island is twice the height of Everest and so massive that Everest could fit inside it 140 times. Geologist Mike Pollan heads to the top of the mountain Mauna Kea, the highest point on the Big Island, to get a sense of its true enormity.
We're standing at the top of Mauna Kea volcano, which is the tallest mountain in the world. It's 13,796 feet above sea level, but it goes all the way down to the ocean floor. It ends up being about 56,000 feet high.
This giant island is the largest in the United States and bigger than all the other Hawaiian islands put together. Intrigued, scientists set out to discover what could have created such a huge landmass. 10,000 feet below the peak of Mauna Kea and 70 miles to the south, the prime suspect is plain to see. The awesome Kilauea volcano.
We like to call Kilauea the most active volcano in the world because it's been erupting continuously since 1983. And it's been going every day, almost nonstop since that time. Since early 2008, it's been even more active because now we have this summit eruption as well. So now Kilauea is perhaps by 2 times the most active volcano in the world.
But this volcano is not predictable. Although the summit is no longer spewing out lava, 12 miles down on the south flank of the volcano is an active vent. For the last 25 years, lava has been gushing out of the side of the volcano from this vent, with no signs of stopping. Homes, towns, and forests are swallowed up by scorching hot lava. With each new flow, layer upon layer of black crust builds, covering the island in volcanic rock. Could this huge island have been built entirely by lava? Experts needed to figure out exactly how much lava Kilauea produces. Their first clue can be found all over the volcano. Clinging to the rocks are yellow crystals. These are sulfur crystals and tell scientists that Kilauea volcano is releasing vast amounts of sulfur dioxide gas. To determine just how much the volcano is producing, researchers take regular measurements.
The amount of sulfur dioxide that effervesces from the magma is tied directly to the amount of magma that's coming out of the ground, the amount of lava that's erupted. So by measuring the amount of sulfur dioxide, we can use that number to calculate how much lava is being erupted.
These samples reveal staggering results. Kilauea could be producing 100 million cubic yards of lava a year, more than any volcano on Earth. But there isn't this much lava flowing across the surface. So where does the rest of it go? Geologists ventured below the surface, into the guts of the volcano to investigate. Stretching 400 feet into the dark is a strange tunnel, just like a subway tunnel. But it's not a man-made structure. It's part of a vast network of tubes that hold the key to how much lava moves around the island.
We're standing in Thurston Lava Tube in Hawaii Volcanoes National Park. And this lava tube was one of the main conduits for lava that was flowing from Kilauea's summit to the sea in an eruption that occurred about 500 years ago. So once this tube system has been established, you essentially have an underground river of lava. So these tube systems can be very long-lived and very efficient delivery systems for lava.
The lava is so hot, it burns a channel into the rocks beneath it. This incredible time-lapse footage shows that because the top of the flow is still exposed to the air, it cools and crusts over. Below this crust, a tunnel forms through which the lava continues to flow. But how much lava can these tubes carry? Back on the surface, Dr. Ken Hahn is carefully inspecting the lava fields to find an active tube. Only inches beneath his feet could be a tunnel full of 2,000-degree lava. Dr. Hahn is on the lookout for a skylight, a window in the ceiling of a tube. They can come and go within days and are a sure sign of an active lava tube.
You can see the lava glowing inside a lava tube. This one's about 10 to 15 feet wide and probably about 5 feet deep. And it's about 2,000 degrees Fahrenheit, and it glows like the sun.
These hidden tunnels keep the lava insulated and hot, preventing it from cooling and turning into solid rock, enabling it to travel further and faster than lava on the surface.
What we're looking at is on the order of about 5 cubic yards every second going in this lava tube underneath us. And that's the equivalent of about a dump truck worth of lava every 2 seconds. So if I was standing on the freeway, what you would see is one dump truck after another dump truck after another dump truck going by me here, transporting a phenomenal amount of material.
Hundreds of these expressways crisscross the island, carrying lava underground up to 30 miles until it reaches its inevitable destination, the ocean. And when 2,000-degree lava meets seawater, the results are spectacular. This interaction is key to how the Big Island was created and is continually growing.
When the lava hits the ocean, it's extremely hot, and it shatters into lots of little pieces. So what it does is leave a lot of black sand behind it.
Layer upon layer of this black sandy rubble slowly piles up on the ocean floor until it forms a new beach. New lava on the surface runs across this beach, cooling slowly to form a new piece of solid land on sandy foundations. This massive island is built on piles of loose rubble.
We're looking right here at the process by which the Hawaiian Islands grow.
The Big Island is the fastest growing piece of land on Earth, as lava from Kilauea adds 20 football fields a year to its already colossal size. But this just isn't enough. More lava is needed to build this huge island, so just where is it coming from? The clues are in the landscape itself. While Kilauea forms only one peak on the island, 4 other megastructures tower over the landscape.
Over 1 million years ago, there was no big island of Hawaii. It started as a very small island, which was the volcano of Kohala, which grew out of the ocean. Over time, more volcanoes started to grow. Mauna Kea and Hualalai came next, growing into tremendous mountains. Mauna Loa was the next volcano to grow. And Kilauea is the youngest of the Big Island's volcanoes.
Over 1 million years, lava from these 5 volcanoes slowly built the Big Island up from the seafloor. The biggest island in the United States is one big volcanic rock. The mystery of how Hawaii was made is slowly unraveling as the evidence emerges from its fiery volcanoes. Experiments in the 1930s revealed that the Big Island is a vast structure stretching 3 miles down to the seafloor. Readings of sulfur dioxide gas show that Kilauea produces more lava than any other volcano on Earth. The landscape reveals that lava from 5 volcanoes built the island. The Big Island of Hawaii is a stunning wilderness dominated by fire and destruction. But what force on Earth could create the most active volcano in the world, 2,000 miles from the nearest land in the middle of the Pacific? Hawaii is filled with evidence of a volcanic past. The 8 islands are made up of 15 mammoth volcanoes. Molokai boasts 2 huge mountains. The Big Island is dominated by the giant Mauna Loa, and in Honolulu, houses are crowded around the now extinct Diamond Head crater. Geologists had figured out that the Big Island was created by 5 volcanoes. Next, they wanted to know how the entire chain had come into existence. 7,000 miles away, off the coast of Indonesia, is the mighty Krakatoa. Ever since it exploded in 1883, scientists have been trying to understand the forces that create volcanoes. Experts plotted all the active volcanoes in the world on a map, and an extraordinary fact emerged. 80% lay around the edge of the Pacific Ocean. This long line of volcanoes became known as the Ring of Fire. 452 giant volcanoes make up the ring, and it is thought that eruptions began in this area over 36 million years ago. During the 1950s and 60s, a theory emerged that finally began to make sense of these fire mountains. Geologists realized that the Earth's crust was made up of 8 major and many minor plates, fitting together like a giant jigsaw puzzle.
They move relative to one another. Sometimes they intersect, sometimes they diverge. These plate boundaries are where we see most geologic activity. For example, along the Pacific Ring of Fire, where there's lots of volcanoes and earthquakes. That marks plate boundary locations.
The theory was called subduction. When tectonic plates collide, the heavier oceanic plate is forced down into the Earth's intensely hot interior, taking water with it. The water forces magma to swirl up and push through the plate where it forms volcanoes. But when geologists looked at the volcanoes of Hawaii, it was clear the theory didn't fit. They couldn't have been created as the plates collided because they sit 2,000 miles from the nearest boundary.
Here in Hawaii, we're in the middle of a plate, so we wouldn't expect to see that much activity. That's another bit of evidence that there's got to be some anomaly here that's causing all of the melting we see in the middle of this large plate.
Puzzled, geologists decided to look at the volcanoes of Hawaii in the hope they might give up their secrets. but all they found were more differences. Most of the world's volcanoes are cone-shaped, with steep sides many thousands of feet tall. But Hawaii's volcanoes look completely different.
We call these volcanoes shield volcanoes because of their shape. You can look behind me at Mauna Loa. It's got these very smooth, sloping flanks. It's like a warrior shield if it's put on its end.
Digging deeper, geologists decided to test the lava and found that Hawaiian volcanoes produce a distinct type of lava called basalt. Basalt lava is made of rocks which have been heated up to 2,000 degrees. Not only is it the hottest lava in the world, it's also some of the most fluid, and this makes it terrifyingly unpredictable.
We gotta get out of here. Get out of here. The lava that erupts here in Hawaii is very runny. It's much runnier than the kind of lavas that erupt from places like Mount Rainier or Mount St. Helens, which is much stickier. It's like comparing honey to toothpaste.
It's this difference in the consistency of the lava that gives Hawaii's volcanoes their dramatically different shape.
The sides of the volcanoes here are gently sloping because those lava flows can just run out as they need to. The lava flows at places like Mount Rainier and Mount St. Helens, being very sticky, stay close to the volcano and build up very steep-sided volcanic cones.
Geologists had uncovered crucial evidence, but they still did not understand what kind of force could create volcanoes in the middle of a plate 2,000 miles from the nearest boundary. But whatever that force turned out to be would have to be enormous. Big enough to quite literally move a mountain. At the summit of the Big Island's Kilauea volcano, Dr. Mike Poland is using sophisticated global positioning equipment to measure changes in the volcano's size.
GPS is a tool for locating yourself anywhere on the surface of the Earth. You may be familiar with this from seeing GPS units in cars. This is a different type of GPS. It's much more accurate, and that allows us to see how the ground is moving at centimeter-level scales.
This cutting-edge technology is crucial to scientists in their struggle to understand the forces working beneath Hawaii.
So we've got this GPS set up here. We also have a GPS set up on the far side of the caldera. Now, by looking at how the distance between those GPS stations is changing, we could get an idea of whether or not the volcano is inflating or deflating. If it's inflating like a balloon, it means that there's magma that's accumulating beneath the surface. And if it's deflating, it may mean that there's magma that's leaving the subsurface. And over the past years, actually, these stations have gotten farther apart from one another by almost a foot. The kind of force necessary to inflate the volcano, to spread the caldera wider by 1 foot, is tremendous. And it's a very good sign of magma that's accumulating beneath the surface and maybe getting ready to erupt.
Evidence was mounting that a huge and unexplained force was at work beneath the chain. The volcanoes of Hawaii do not emerge from a plate boundary, but rise up right in the middle of the Pacific Plate. Hawaii's lava is dramatically different to that produced by the rest of the volcanoes in the Pacific. The islands of Hawaii were a thorn in the side of geology. But although they remained an unexplained mystery, geologists weren't about to give up. And the answers they would find were so incredible that the debate they created still rages to this day. The puzzle of what created the islands of Hawaii seemed impossible to solve. The mystery only deepened when in the 1950s the U.S. Navy mapped the ocean floor with sonar. They revealed a series of underwater mountains, known as seamounts, that extended far beyond the chain of 8 Hawaiian islands.
To the northwest are a whole string of seamountains we call seamounts. Those are sunken volcanic mountains, many of them with reefs on top of them.
Over 80 seamounts and 19 islands form this sequence, known as the Hawaiian Emperor Seamount Chain.
You're looking at a total distance from the Big Island of Hawaii out to Midway and all the way up to Russia of about 3,200 miles. It's one of the longest mountain chains in the world, but very little of it is above sea level.
In 1963, Canadian geologist J. Tuzo Wilson turned his attentions to the Hawaiian Islands. He was struck by the fact that both the Hawaiian Islands and seamounts form a straight line that courses through the middle of the Pacific. Straight lines are incredibly rare in nature. They don't occur by accident, especially not a line over 3,000 miles long. Wilson believed that one single force must have created this vast chain of volcanic islands and seamounts. Wilson also made a very simple and yet incredibly astute deduction. The further the islands of Hawaii were from the Big Island, the greener they got. And for Wilson, greener meant older. He noticed that the landscape on the Big Island is like a black desert, a barren wilderness with only a few seedlings peeping through the lava. Fresh lava flows regularly scorch the earth, killing any plant life. But move north along the chain and the islands become increasingly green. Wilson believed that on each successive island, more time has passed since the last eruption, allowing more plants to grow. 2 years later, using radiometric techniques, scientists dated rock samples from each of the islands. Their results confirmed Wilson's hunch and proved that the islands increased in age. Dr. Poland has been collecting some of these rock samples and has brought them to the Big Island.
This rock right here is from the lava flow that we're standing on. This is one of the youngest rocks on the island. And in fact, we could go and pick up some lava that formed yesterday if it weren't too hot. We move down to the middle of the chain, we get this rock here, which is from Oahu. And this is about 3.5 million years old. This rock here is from a lava flow on the island of Kauai. It's from the island that's the farthest away from where we are today on the Big Island. You notice how dull it is. That's because it is very old. It's about 5 million years old.
Wilson pulled together evidence from rock dating and the straight line forged by the islands and came up with a single theory. He proposed that Hawaii was created by something called a hotspot, an exceptionally hot region beneath the Earth's crust that was concentrated under Hawaii's Big Island. As the Pacific Plate moved slowly over this hotspot, the immense heat punched through the crust to form a chain of volcanic islands.
So this hotspot is a constant and stationary source of heat beneath the Earth's surface. It's like a blowtorch pointed up at the surface of the Earth. And as the Earth's surface moves over that blowtorch, it punches through, creating a chain of islands and undersea mountains. And that's what we're seeing in Hawaii today.
This theory was a geological masterstroke. It didn't just explain how Hawaii was created. It also confirmed one of the most radical theories of the 20th century, the theory of plate tectonics. Here at last was evidence that the vast lumbering plates that made up the Earth were moving. Tuzo Wilson's hotspot theory changed our understanding of our planet forever, but it also left behind a controversy that still rages to this day. How was the hotspot created?
So ever since scientists understood that volcanism in Hawaii was driven by this hotspot, the question then became, well, what drives the hotspot? What causes the hotspot?
On the barren slopes of Mauna Kea on the Big Island, Mike Poland has found a clue.
So what we're looking at here is what we call a xenolith. It's basically a foreign piece of rock that's trapped in this lava flow.
It's where this foreign piece of rock has come from that's truly startling.
The green mineral you're seeing in this xenolith here is a mineral called olivine, and it really indicates that this chunk here came from someplace very deep within the Earth.
Olivine is usually found hundreds of miles beneath the surface. Its presence here is good evidence that the hotspot is powered by something deep within the Earth. And in the 1970s, American geologists finally came up with a groundbreaking theory. They theorized that below the hotspot lies a plume of hot rock which rises up through the Earth's interior. 200 or 300 miles below the surface, it starts to spread out, forming a huge dome. The very top of this is the hotspot. Scientists call this phenomenon a mantle plume. No one really knows how deep it goes, but some scientists have come to the extraordinary conclusion that it may stretch all the way down to the very core of our planet.
It is possible that the plume extends all the way down to the core mantle boundary. And frankly, that makes good sense to me. If you look at the size of the Hawaiian island chain, it's a huge feature. It's been around for tens of millions of years. To me, that's not something that can be explained by something that's just near the surface. I think it's got to be something quite deep within the Earth.
Suddenly, experts realized plumes were the answer to hundreds of geological mysteries which had long puzzled science, such as the existence of Icelandic volcanoes, the Galapagos Islands, and the vast Yellowstone supervolcano. An investigation begun in Hawaii transformed scientists' understanding not just of the island chain, but of the entire planet. Rock dating and the unusually straight alignment of the island chain revealed that the Pacific Plate is moving over a stationary hotspot. Olivine rock, erupted on Hawaii's Big Island, shows this hotspot is powered by a mantle plume originating from the very bowels of the Earth. But while the Hawaiian Islands have been created by this very hotspot, another equally powerful force is working to destroy them. In Hawaii, a strange force is at work. While the Big Island is growing by 11,000 square feet a year, the islands at the northern end of the chain are vanishing into the Pacific at a rate of 2,400 square feet a year. These islands are disappearing fast. Geologists were curious about what force could cause them to vanish. They found their first clue in early scientific studies. 1950s underwater sea mapping produced a wealth of data, and these results revealed something completely unexpected. Heat and pressure from the hotspot had forced up the ocean floor, creating a bulge 750 miles long and 500 feet high. The chain is raised by the swell, but as the islands move away from the hotspot, they slide off the swollen crust, sinking further and further.
Eventually, as they move northward at about 8 to 10 centimeters, that's about 3.5 inches per year. So in, say, another 1 to 2 million years, this island will probably be as much as 3,000 to 4,000 feet lower, probably have relatively little fresh water on that, and not be very inhabitable.
The hotspot that created the islands also seals their fate. But the islands aren't just sinking, they're shrinking too. Erosion is the culprit. It's slowly destroying the islands, and nowhere is this more apparent than on Kauai, the oldest island of Hawaii. Here along the coastline, intense weathering may have produced some of the most breathtaking natural features in the world, but it is also evidence of the island's inherent flaw. And erosion isn't just taking place at the coast. It's happening all over the island. Waimea Canyon, Hawaii's Grand Canyon, a 10-mile scar through Kauai's green wilderness. Over 3,000 feet deep, this canyon is the most dramatic example of erosion in Hawaii.
If you look up to the east, you'll see one of the rainiest places in the world, Mount Waialeale. Rain flows from that mountain down into the canyon.
Mount Waialeale receives over 400 inches of rain every year, which pours out over the island, carving out the canyon. But the islands are made of basalt lava, one of the hardest rocks on Earth. How could water alone be wearing them away? The answer lies in the canyon's spectacular red walls.
The reddish color is from the oxidation of the mineral iron, which makes up about 10 to 12% of the lava rock here. It's very similar to the rust that forms on your car. So literally we're looking at a highly rusted landscape, if you will, which makes it very soft. So in a sense, it's somewhat rotten.
Exposed to water, the high level of iron in this lava causes the rock to rust and crumble. It's the paradox of the Hawaiian Islands. They're made of volcanic basalt, one of nature's hardest rocks, but it's fatally flawed.
This rock, which initially was a very dense, hard lava you can barely break with a hammer, we can now actually pull out pieces with our hand.
Combine this crumbling rock with some of the highest rainfall in the world, and the result is massive erosion over millions of years. But scientists knew that erosion alone couldn't be causing the islands to disappear. On the island of Molokai, they found evidence that vast tracts of land had disappeared not over millions of years, but overnight. Satellite images revealed that Molokai is not like the other round islands of Hawaii.
Something strange happened to Molokai is quite obvious just by looking at any map. It's not a round volcano. Part of it is missing.
It's a thin strip of land with sharp cliff edges, shorn away into steep faces. At 1,700 feet, these are the highest sea cliffs in the world. All the evidence pointed to a sudden cataclysmic event. Many theories were put forward, but it wasn't until the 1980s that geologists got the evidence they desperately needed. After the success of earlier underwater mapping, the U.S. Navy returned to Hawaii with the world's most advanced sonar system and surveyed the surrounding waters in incredible detail. They discovered the seabed on the island's north side was littered with gigantic underwater blocks of land, some larger than the island of Manhattan. Geologists took thousands of samples and measured the blocks. What they found was incredible. These blocks could be fitted back to the island's steep cliffs like a giant jigsaw puzzle. Finally, scientists had enough evidence to put together a picture of what had happened. Radiometric dating confirmed the age of the blocks and showed that they were the result of an event which had taken place over 1 million years ago. Geologists knew there could only be one explanation: a massive landslide.
1.5 million years ago, there was a very bad day in the Hawaiian Islands. The entire north slope of the island slipped off into the ocean, a section 25 miles long and perhaps as much as a mile thick. And it did it all at once.
This huge section of the island crashed into the ocean, splitting into massive blocks weighing millions of tons. The force with which they crashed into the waves meant they didn't stop dead, but continued to move along the ocean floor at an incredible speed.
It was sudden, it was dramatic. And we know that because of how far the blocks went. They went down into this trough around the Hawaiian Islands and then up the other side, and eventually stopped about 200 miles away. And for them to go that far means they had to be traveling about 150, 160 miles an hour, really fast. And of course, it's displacing water while it's doing that, so you're creating, for the Hawaiian Islands, a huge tsunami, a tsunami that would have reached to the top of the cliffs behind me.
A landslide on this scale and at this speed would have produced one of the most awesome and deadly waves ever seen on the planet.
The main event was over in only 5 minutes. And I'm afraid that if you saw that, it would be too late, because you could run as hard as you like and you wouldn't get away from the subsequent tsunami.
But what could have caused such catastrophic land failure? Geologists look to the youngest island, the Big Island, for answers. Here, the island is still building, just as Molokai once did, and experts suspect they will find their answer in the island's foundations.
As the new land builds out, it's building on sand that's deposited in front of the lava flows, and so it's very unstable. Every once in a while, this material collapses, leaves the lava unsupported, and it breaks and it slides down into the ocean.
It was a disturbing discovery. All Hawaii's islands were built rapidly and entirely from lava. They are all based on the same weak foundations. And that means a landslide could strike anywhere. On the south coast of the Big Island, there's evidence that another major landslide could be about to occur. A huge tear in the earth points to where a 4,700 square mile chunk of land is breaking away from the Big Island at a rate of 4 inches a year. For its size, this is the fastest moving tract of land on the planet. Geologists have calculated that if it were to fall into the ocean, it could trigger an earthquake up to magnitude 7 and unleash a colossal tsunami. All the cities of Hawaii would be swept away as a mammoth wave races toward the California coast. Investigators have discovered why Hawaii is disappearing. Sonar maps reveal the islands are sliding off a swollen section of the Earth's crust. Kauai's crumbling landscape reveals an inherent flaw in the islands. They are made of the hardest rock on Earth, but exposed to water, they rapidly break down. And Molokai's dramatic cliffs shorn away overnight are evidence of catastrophic landslides. Sinking, eroding, and crashing into the Pacific. Eventually, even the Big Island will be just another underwater mountain in the long chain, hidden beneath the waves. But the story of Hawaii is far from over. Rumblings from under the sea tell scientists a new monster may be rising from the waves. Now they must venture into one of the most hostile environments on Earth, where fire meets water. The story of Hawaii is an incredible tale of giant volcanoes, unimaginable catastrophe, and vanishing islands. But it doesn't end here. Because only 20 miles off the Big Island's beaches, something strange is stirring in the depths. In the 1950s, seafloor surveys revealed that an underwater volcano sat right on the flanks of the Big Island. Geologists were intrigued by this giant seamount rising up 2 miles from the ocean floor and named it Loihi. Scientists were desperate to learn more, but it wasn't until 40 years later, when the technology became available, that they were able to dive down and investigate the seamount.
Scientists were very interested to go down and actually see what the situation was. So they took the research submarine Alvin, this is a very famous 3-person sub that found the Titanic, and they went down to the seamount and found that there was a huge pile of volcanic rocks that were all freshly broken. And here's a sample. This is a very heavy rock, and it's atop of a pillow lava.
Pillow lava was evidence of a very recent eruption. Scientists had believed Loihi to be an ancient volcano, extinct for thousands of years. But this discovery called for some radical rethinking. Could Loihi be alive and erupting? Experts struggled for 11 years to find indisputable proof, mapping the seamount extensively and taking thousands of samples, until finally they came across the piece of evidence they had been searching for.
Now, it wasn't until 1996 that really the smoking gun was discovered. In October of that year, there was a huge number of seismic events occurring that the people at the Volcano Observatory discovered, but they quickly realized that the source of the seismic activity was not on the island here, it was offshore. They did the best estimates they could, and it all pointed to the seamount off the south end of the Big Island.
This swarm of earthquakes coming from Loihi were the largest number ever recorded from any Hawaiian volcano. Scientists knew they were on the verge of an incredible discovery. Desperate to witness the action as it happened, scientists rushed to the heart of the activity.
The trick was to get out there while the eruption was occurring. So we went out there. There was a tremendous amount of seismic activity. From the ship, you could actually hear the noise of the earthquake.
Venturing into the unknown, a team from the University of Hawaii dived 3,000 feet down into this dangerous and unpredictable environment.
Everywhere you could see were mounds of broken up rock. And this murky water was this precipice. So the top of the seamount had suddenly collapsed to create this pit crater that was hundreds of feet across and hundreds of feet deep. And this was the first evidence for really active volcanic activity.
Experts had just missed one of the most violent eruptions Hawaii had ever seen. But as the dust settled, they were able to survey the aftermath. Lava had poured out of the volcano, draining the summit and causing it to collapse. The team finally had proof that Loihi was an active volcano, which will continue to erupt and grow until it forms a new island, the next in the Hawaiian chain.
The assumption was there had to be another volcano coming up one of these days. No one knew whether that was going to happen in our lifetime or not, but it's very rewarding for the scientists to realize that now the next volcano in the sequence has been discovered. Loihi is apparently it.
As lava continues to spew from its submerged summit, Loihi will build until it rises out of the Pacific. The Pacific plate will shift, carrying the Big Island off the hotspot, and Loihi will take its place at the head of the Hawaiian chain. Experts had studied the ancient islands of Hawaii for hundreds of years, theorizing about how they were created. But they never imagined they would have the opportunity to witness it for themselves.
Loihi provides us with a real unique laboratory. It gives us a window back into the past. This is our one chance to see how it worked before the islands reached the surface.
Reviewing all the evidence, investigators finally understand how the Hawaiian chain was created. Gravity readings taken in the 1930s show that the Big Island is 140 times bigger than Mount Everest. Further investigation reveals that it is made entirely from basalt lava from 5 volcanoes. Rocks created deep underground are found within the lava and show the island's volcanoes are fueled by something from deep within the earth, a mantle plume. But high levels of iron in Hawaii's basalt lava caused the islands to crumble, and the steep cliffs of Molokai are evidence of mega landslides. Underwater lava is proof that a new volcano is stirring, the next island in the chain that will eventually emerge from beneath the waves. Hawaii's dramatic cycle of birth and death is more than just a geological wonder. It's transformed geologists' understanding of the entire planet. On Hawaii, we can see for ourselves how the Earth is made.